Ray Schmitt is oceanographer and a weatherman. He's the founder of Salient, a weather company, and also on the board of the Climate Foundation that recently was awarded the Xprize. Ray, welcome to EarthX.
Well, thank you. It's been a great meeting.
So you are a weatherman. And what have you figured out about the weather? Why do you start your own weather company?
Well, it's a long, interesting story, I think. I'm an oceanographer who studies the water cycle. And I discovered some years ago that I could look at the patterns of the change in ocean surface salinity, and I figured out how to predict rainfall on land. The idea is when water evaporates from the ocean, it makes it saltier. If it rains on the ocean, it gets fresher. So if I look at the records of ocean salinity and see that some patch of ocean has gotten saltier than normal, I can guarantee you it's going to rain more than normal somewhere else. Well, we've been able to connect the dots, from some of the patches of the ocean to regions on land. For instance, we can look at salinity off the U.S. coast, the U.S. East Coast from New York to the Gulf, and look at springtime salinity, and then predict the rainfall in the upper Midwest in the summer, the following summer, 3 months later. It's quite a powerful tool. And there's a complex interaction with the atmosphere that goes on there. But the salinity is a good indicator of what the water cycle is doing and where it's going to rain in the future. And so
now we are, of course, nowadays addicted to these devices, and all of us look at our device and say, what's the weather going to be tomorrow?
Yeah.
Now, will what you have discovered, will that impact ultimately my experience when I look at my device and see what tomorrow's weather is?
Possibly, possibly. So what we did, we were developing this research technique, basically, and publishing papers about it. And then I've heard about a rainfall forecasting contest for the U.S. West that's sponsored by the Bureau of Reclamation, who manages a lot of the dams in the West. They needed to know longer range forecasts. And I said, well, we're pretty good at that. And around the same time, I found out that my identical twin sons were using machine learning to play computer games.
Yes.
And I said, well, look, guys, here's this contest with big prize money. Why don't quit playing games? Let's enter a real contest. Well, it was a lot of work. We had to produce new forecasts, a 3 and 4 week lead, 5 and 6 week lead for all across the West every 2 weeks for a whole year. So you had to be consistent. And I gave them the data. They trained up the model, and we tried it. And right from the beginning, we were the leader in the contest. And it was a horse race. Every 2 weeks you got an update on your score. And we stayed ahead the whole time. We walked away with $250,000.
Unexpected. So much for computer gaming, video gaming.
I guess I shouldn't criticize
No.
the time they wasted on games. So we recruited my last graduate student at the Woods Hole MIT program to join us, and the 4 of us formed this company. And since then, we've expanded, hired a lot of people, raised a lot of money with grants and investments, and we're now up to 18 people. We have contracts with a lot of big companies, and so it's an exciting time.
Because rain, of course, predicting rain can be enormously important for agriculture and things like that. And I assume that's where the contracts are, in these kind of...
Well, our early customers, our first customers, were in agriculture.
Yes.
Lately, we find that there's a great demand for temperature forecast because of its implications for energy demand. If it's going to be hot or cold, they call it heating degree days, cooling degree days. That determines, in the winter, it's how much natural gas is going to be consumed. In the summer, how much electricity for air conditioning. And we found that our models, our forecasts, are more accurate and more reliable than NOAA's. And so when there's a divergence, sometimes we pick up things that NOAA doesn't pick up. And sometimes they get false alarms that we say, oh, that's not going to happen. So a person who's dealing in energy trading could make a lot of money doing that. And so we're leaning into that business now.
Is, generally speaking, you have a longer term forecast than, for instance, as I refer to it, see on my phone?
In our most recent model, we realized there's still a lot of demand for the short-term forecast. So we've gone to shorter timescales. And so now we're producing a new forecast every day, and we release it 20 hours ahead of the NOAA forecast and 12 hours ahead of the European forecast. And it goes out longer. We go out 100 days. Theirs only go out about 30 days. So it's a real advantage for energy traders and commodity traders. So we're very excited. We think it has the possibility to scale quite large.
It could be very important for places like India that is completely dependent on the monsoon, for instance.
Yes. Yes, India suffers greatly when there's a drought, and flooding can destroy whole villages and wipe them out. So it's very important stuff for the long-range forecasting.
I need to ask you something from very much from personal interest, but I live in Santa Barbara in California, where there's always fog. Can you tell me more about fog than other models can? Because the fog is a frustrating experience.
Yeah, fog is a hard thing to predict sometimes. Yeah, but basically what it is, when the atmosphere will hold more water when it's warm, so you can have warm, moist air that's encountered the cold ocean. And so you'll get this low-level fog. And on land, of course, at night, it can really cool off from radiational cooling. And so the fog will form. Probably a lot of it is the marine layer coming in in a coastal area like Santa Barbara.
So that is next level of research and gaming.
Right now we're focused on temperature precipitation. The energy supply for renewables, wind, solar, and hydro, and also the energy demand, which mainly temperature dependence.
Let's talk about your other project or your other activity, being on the board of the Climate Foundation.
Yes.
Also a successful project. What happened there? Why did they get the prize?
Yes, that's very interesting. So there was a fellow who was the son of a Woods Hole scientist. Woods Hole Oceanographic Institution is a world-renowned center for oceanographic research, and I knew this fellow's father quite well. And this is a very bright young guy. He went to Caltech and got a PhD in computer science. And he had a company back in the 90s and the early dot-com boom. And he was able to sell his company and make a lot of money.
Video gaming again. Video game also.
Well, it wasn't gaming. He made it designed a certain kind of computer chip.
Yeah. Okay.
He made a lot of money.
Yeah.
And he realized he was set for life as a fairly young person, but he knew about the climate problem long before it became fashionable, and so he started the Climate Foundation. He's a very bright and energetic fellow, and in the course of time, he set up an operation in Woods Hole. He was mostly living on the West Coast, but every summer he'd come to Woods Hole. When he bought a house, he used it kind of as a dormitory, and he would bring in a whole troop of students from Princeton, and they would work on the problem of sequestering carbon in the ocean. And he wanted to use what we call macroalgae or seaweed or kelp. And the reason is there's another technique called iron fertilization, and that generates lots of microplankton, very small diatoms and such. But the macroalgae actually sequestered carbon more efficiently for the use of the nitrogen and the phosphorus, about 3 times as good as what you do with phytoplankton. So he was very interested in fertilizing kelp. And so he came to me, and I would see him around every summer, and I was advising him on how you could bring up nutrients from the 100 meters down in the ocean where there's plenty of nitrate and phosphate, and bring them up to the surface to fertilize the macroalgae. Well, we talked about that for a long time. He did experiments. Ultimately, he realized that wasn't the way to go. So he developed a new idea, and that's to move the algae themselves up and down. And the idea is does a circular hula hoop sort of thing, anchored in the middle, and the algae is growing all these ropes, like spokes of a wheel. And so you pull the thing down at night, and the algae absorb the nutrients. You come up during the day, and it photosynthesizes and generates, that's exactly what we want to happen. We want to get, see, one of the big problems in the ocean is that all the warming that's going on is stratifying it. So there's not as much mixing, not as much nutrients getting to the surface. So there's a loss in ocean productivity, which means fewer fish. It's a big problem. But this is a way to get nutrients into the macroalgae and photosynthesize during the day when the thing's at the surface. But there's other benefits. This is a structure in the ocean. I've put a lot of things in the ocean, and it's a tough environment. Well, if a typhoon is coming, he's been doing a lot of work in Indonesia and the Philippines and Australia. If a hurricane or typhoon's coming, he can keep it down for a day or two while the thing passes and then safely come up, and so the thing can survive hurricanes. The algae itself, there's a real market for it in Asia. I mean, it's food, it's consumable there. You can convert it into a growth stimulant, a fertilizer, for crops. You can feed it to cows to reduce their methane emissions. There's lots of uses. So his tactic is to actually develop a real market for these things. And a side benefit is, as the algae is consumed, or some of it will fall off and sink to the deep ocean, and some will be consumed by fish and other things, and they'll cycle it, and ultimately their fecal pellets will make it to the deep ocean. So you're putting carbon into the deep ocean. And that's where it needs to go. The ocean has 50 times as much CO2 as the atmosphere. So if we wanted to cut the CO2 content of the atmosphere in half, it means only about a 0.5% increase for the ocean, which is really nothing. You put in the deep ocean, it's not hurting anything. And if you put it all the way to the bottom of the ocean, people talk about bailing up seaweed and putting it on the very bottom. Yeah, there's oxygen down there, so there would be creatures that would consume it down there. And once you get it deep, it's deep for thousands of years. So that's the real goal, is to sequester carbon. So on land, when you fly over the Midwest, you look down out of the airplane, you see all these crop circles from the circular irrigation tubes, and they're pumping up groundwater to water their crops, their corn or alfalfa. Why can't we do something similar for the ocean, where no one's living, and it wouldn't interfere with shipping because you keep it down. You can keep it out of the way of a ship coming, if you know what's going on. And so you could have these crop circles in the ocean that are enriching the productivity of the ocean. So more fish, more carbon sequestration. And
all the things we want.
Yeah.
More biodiversity. And how big are these structures?
Something like 1 square kilometer is what he's talking about now.
This is a serious size. Yeah, that does look like these crop circles.
So I've been on his board for a number of years, and we're working with him for, probably 20 years or so. And a few years ago, he applied to the the Xprize Foundation, gives out prizes, and there was one sponsored by Elon Musk, actually, for carbon sequestration. And they gave various prizes. And we got a $1 million prize for the seaweed project. And so that really helped get things going. But we've raised a lot of money from other foundations and things, a lot of grants, the Gates Foundation, other foundations have helped out a lot too.
So you see things from both sides. You, as weatherman, you see how bad the weather has changed. How badly has this changed over the recent decades?
Yes.
And more severe storms and more heavy rainfalls, more droughts, all of that, which is the bad news. And then you work for the Climate Foundation, and then let me say first, the bad news caused by too many carbon emissions.
Yes.
And then, okay, what are we going to do about that? That's your work with the Climate Foundation. But Within these two forces, if you like, the negative and the positive one, what is winning?
Oh, I'm afraid the negative one right now. I'd actually like to talk about that. The severity of the storms is really a much bigger problem than people realize. And people talk about sea level and stuff with climate change. That's a long-term problem, centuries actually. But the change in the water cycle, which is my expertise, is what's really hurting us right now. And it's because of the properties of the water molecule. I'll mention two things. One, it has the vapor pressure is an exponential function of the temperature. So for every degree centigrade that we warm up the planet, 7% more moisture is carried in the atmosphere. And that's a big problem because that exponential function means we're really hitting a wall and it's going up very, very quickly. And the water molecule itself is very light. H2O is much lighter molecule than O2 and N2, the main constituents of the atmosphere. And so when you have high moisture from the soil or the ocean, you have evaporation, that is very buoyant. And that has to go up. And when the air goes up, some air has to come down to replace it. And so right now what's going on is we're reaching higher into the atmosphere for those strong winds in the jet stream, and they're coming down. You're getting stronger tornadoes, stronger straight line winds we call derechos. So it's amplifying all the problems of storminess. But there's another factor which kind of surprised us, and recent research has shown. It kind of contradicts what we were hoping for 30 years ago. 40 years ago, we used to think, well, more moisture in the atmosphere would mean more cloudiness, and that would reflect the light back out into space, the sun's energy. Well, that's not what's happening. Because of this crazy exponential ramp up in the vapor pressure, the threshold for rain to form has gotten higher. There's a higher threshold. So what's happening is the rain events are getting more intense and they're getting narrower. So the rain areas, in the tropics, we call the intertropical convergence zone, it's gotten narrower in the last couple of decades and more intense. And then on land, things like the atmospheric rivers that hit California are getting narrower and more intense. And in the middle latitudes, the subtropics, they're actually getting less cloudy. So more energy is going into the ocean. And the ocean is absorbing most of the energy of global warming, over 90%. And so that hot ocean is just fuel for hurricanes and feeding, increasing the severity of all the storms with the physics of that water molecule.
From what you know, what do we need the most? What is your dream that could happen that would help us?
Yeah. We really have to ramp up solar and wind energy. And my weather company, what we're doing is trying to do forecast for solar, wind, and hydro so that people will know how much renewable energy is available in the next weeks and months ahead. And we're also looking at the energy demand, mainly based on temperature, heating degree days, cooling degree days. And so that's why we've kind of pivoted to the energy market lately. That's kind of solving the immediate problem. But we do have to reduce our carbon emissions, and we have to figure out ways to take carbon out of the atmosphere. And so that's what we're doing with the Climate Foundation work. Hopefully that'll get there, but we have a long way to go. These ocean techniques, the ocean is the place we really need to put all that carbon. But there's a lot of research, it's going to take decades to really make it effective.
Are you able to remain optimistic somewhat?
Yes, I think we're going through challenging times. I'm a person who likes to solve problems, and so I have good physical intuition, and I like to connect the dots from everything I learn. And so I'm optimistic that mankind can do it if he's given a chance.
Thank you, Ray.
Thank you.